Today we study Calculus 1. The topic is the derivative. Now we look at, in the physics, we know how to compute the instantaneous velocity of the linear motion. How to find the instantaneous speed vt0 at the time t0. We know if the distance function s satisfies s equals st. And then if t0 tends to t0 plus t is a changeable time. How to understand changeable time means t0 is a fixed time. t0 plus t changeable. The increment is t. Corresponding the distance s equals s bracket t0 plus t minus distance t0. The distance is given, and then the corresponding mean velocity. The mean velocity v bar bracket t. This means the mean velocity is a function of t equals the distance over the time. How to get the instantaneous speed? There are two cases. Case 1, if the linear motion is uniform motion. Now the question is simple. At this time, the instantaneous velocity vt0 equals v bar, means equals s over t. Look at the case 2. If the linear motion is non-uniform motion, at this time, t is changeable. How to understand t is changeable? This expression means the difference of the two distances. The distances over t is a function of t. If t is very small, means enough small, t tends to 0, the limit exists, means the limit is our instantaneous velocity, means equals the limit. It is called the instantaneous velocity vt0 at the time point t0. Now we look at another question in the geometry. Geometry means how to compute the tangent line of some curve. Look at the figure. The figure means y equals fx is our pink curve, giving the point mn. How to understand the black line? The black line mn is our segment line. The right line mt means the tangent line. How to get the slope of the tangent line? Look at the tangent line mt is the limit position of the segment of fn. And the condition means capital N tends to capital M. If capital N tends to capital M, the 2 points may be on the same point. At this time, means the limit position if the distance of mn tends to 0, means n tends to m, corresponding the angle nmt tends to 0. At this time, let the pink curve function is y equals fx. Find the corresponding slope of the tangent line at the point m0. How to compute? Look at, if let capital M is given corresponding x0, y0, capital N, xy, n is changeable. N how to change? Okay, n along the pink curve tends to capital M, means n, xy are changeable. The slope of mn, how to compute the slope of mn? M is given, n is given. According to the knowledge of high school, we know tangent phi corresponding the angle equals y minus y0 over x minus x0. So this expression tangent phi is given equals y is fx, y0 is the value of f bracket x0 over x minus x0. If n tends to m, pay attention to the limit position along the curve C at this time x tends to x0. So the slope of the tangent line mn, k equals tangent alpha. Look at the figure. Tangent alpha means the angle between the tangent line, okay? So k equals tangent alpha. Tangent alpha equals the limit position, means the limit x tends to x0, fx minus fx0 over x minus x0. If the limit exists at this time, it is the slope of tangent line. So now, according to the special cases in physics and geometry, we give the definition of derivative. So now look at the derivative of a function f is another function f prime. Pay attention to read it as f prime, whose value at any number x is given as the following. F prime x equals limit f bracket x plus h minus fx over h. Limit. The condition means h tends to 0. Pay attention to h is our changeable variable. If the limit does exist, we will say f is differentiable at the given point x. Otherwise, think if the limit does not exist, we will say that f is not differentiable at the given point x. Pay attention to the h. H is the same variable. The same variable expression tends to 0. Try to understand the formula. So now look at another form. Remark 1. For any point x, we can write in some other forms. Look at case 1. F prime x. Do you remember? Yes, it is some limit. So f bracket x plus delta x minus fx over delta x. Condition? Yes, the same variable tends to 0. Pay attention to delta x, delta x, delta. They are the same expression. Of course, we can write it in another form. Look at the form 2. F prime x. Sometimes we write it delta x. Maybe you like another letter h. So we can write it plus h over h tends to 0. They are the same meaning. Different expression, but the same limit. Look at another form. Look at the case 3. F prime x. 1, 2, 3. The 3 expressions are same. Well, of course, we can write it like this. Minus h, minus h, minus h. So, you should remember the basic form. Variable, variable, variable tend to 0. Now, we can look at remark 2. For some fixed point x0, write it in some another forms. Look at case 4. Now, at the given fixed point x0, f prime x0 equals limit f. Do you remember case 1? Case 1 means any point x. Now the point becomes x0. x0. So we write it, okay? x0, x0. 0 plus delta x over delta x. Delta x tends to 0. Look at case 5. F prime x0. We can plus the same expression. So plus h over h. h tends to 0. We can get f prime at the given point x 0. Look at case 6. F prime x 0, we can write the changeable variable in any form. We write it minus h. Of course, it's okay. So minus h, minus h, minus h. Try to understand the above formulas. So now look at, if f prime x 0, sometimes we can write it f prime x giving x equals x 0. Means f prime x 0 is some value. It's the value of the function f prime x. So if special case x 0 equals 0, at this time f prime 0 equals the limit fx minus f 0 over x minus 0. X minus 0 equals x. So sometimes we write it, the derivative at the given point 0 in this form. According to the formulas, we can do some example. Now look at example 1. If fx is a derivative at the given point x equals a, try to find the limit x tends to 0. How to find the limit? Using what? Yes, using the definition of derivative. So now, do you remember the definition? F prime at any given point x 0 may be equals 5, maybe equals a, maybe equals any given point plus h over h tends to 0. Pay attention to, they are the same changeable variables. So now we write the original limit equals, we look at what is our h. Which term is our h? Yes, 3x. Do you remember? It's our a means x 0. 3x is our h. So we're making up h over h. How to making up? Yes. fa plus h over h equals 3x. So we should write plus h over h, but it is equal. So equivalently, times some constant means times 5 over 3 together equals 5x. So go back itself. Now it's equal. You'll be happy. Why? A plus h. You can tell me, oh teacher, 3x tends to 0. Yes, h means h tends to 0. Pay attention to. This means 3 is a constant. This means x tends to 0. So we write the limit condition x tends to 0. So now we can write it in this term 3 over 5 times the limit. The limit exists. Yes, the given condition tells us fx is derivative at the given point. So this expression is our definition equals f prime a. It is our final answer. Try to understand the question by using the definition of derivative. Pay attention to h tends to 0. H tends to 0. In short, x tends to 0. If we understand example 1, we try to understand example 2. Now look at, if f equals 1 over x, find f prime x. How to do? Yes, according to the definition. So now finish this. F prime x for any given point equals limit. Do you remember? Plus h over h tends to 0. Yes, the definition. fx plus h. What is our fx? fx equals 1 over x. How about f2? f2 means 1 over 2. How about this term? fx plus h means 1 over x plus h. So your copy corresponding expression. We write it 1 over x plus h. Pay attention to the limit condition. H tends to 0. How about x? x is some fixed real number. So x is regarded as a constant. H is changeable. So we write it equals minus 1 over x squared. Why? Pay attention to the limit condition. H tends to 0. X is some fixed number. Look at this. This means 1 over x prime equals minus 1 over x squared. Try to remember this expression. It's useful for your future study. So now look at example 3. Try to find the derivative of the function f(x) equals c. C is a constant. This means constant function. Means x belongs to any real number term, and this time the value is always equals c. How about the derivative? Of course, according to the definition, write it. Definition. F prime at any point, it is our definition. Remember. So now look at fx is equals c, f5 equals c, f6 equals c. How about this value? F bracket x plus h, of course, equals c. So equals c minus c. Limit c minus c over h. H tends to 0. Pay attention to this term. C minus c equals 0. 0 over h equals 0. Limit 0 equals 0. So we look at the beginning term and ending term. F prime x equals 0. So this means c prime equals 0. It's very useful in the future study. Any constant corresponding prime equals 0. This means 2 prime equals 0. This means line 3. Why? Line 3 is a constant. The constant prime equals 0. This means pi. How about pi? A constant. Pi prime equals 0. Why? Because our result, any c prime equals 0. So now look at example 4. Let the function f(x) equals sin x. Try to find sin x prime and the corresponding prime value at the given point, pi over 4. How to do? The first, according to our definition. Yes. So now look at the concrete steps. Sin x prime equals the definition. Limit f bracket x plus h minus fx over h. H tends to 0. Some students don't understand this step. Why write it in this form? So now we write the definition. For every point f prime x equals what? Yes, equals the limit h tends to 0 f x plus h minus f x over h. In this special example, f means sin. So fx, write it as sin x. This term fx plus h means sin x plus h over h. How to do? Sin alpha minus sin beta, write it. Limit h tends to 0. Copy the limit signs. H copy sin alpha minus sin beta equals cosine x plus h over 2 times sin h over 2. Do you remember the important limit? Sin some variable over some sin variable. If the variable tends to 0, at this time the limit equals 1. So this limit equals 1. H tends to 0. This term means cosine x plus 0 means cosine x. So the final result, cosine x times 1 equals cosine x. Pay attention to the limit. In this expression, h is variable. How about x? X is some fixed point. you can look at x is a constant. So equals cosine x plus 0 times 1 means cosine x. Look at this. Sin x prime at a given point means cosine x at a point value equals what? Yes, equals square root 2 over 2. We have known this point in high school. We have the result. Sin x prime equals cosine x. Remember, in the similar way, we can get similarly cosine x prime equals minus sin x. Try to remember the signs, okay? Equals minus sin x. So now we look at the summary of the derivative. The first, it is what? Our definition. Very important. F prime x equals the limit, the increment over h. H is the same expression. F prime x, we can write another form, equals the limit delta y over delta x. Delta x tends to 0. What is our delta y? Delta y means the increment of the function y means the expression, special case. We can write it in this form, delta y over delta x. Look at f prime x, 0. This means the derivative at some given point x0. F prime x0 equals the limit fx minus fx0 over x minus x0. Condition delta x tends to 0. This term is our delta y. This term is our delta x. Try to understand, okay? So now, special case. If f prime 1, f prime 11, any real number, for example, f prime 1. 1 means the given point equals 1. So this term becomes 1, 1. So we can write it f1 plus h minus f1 over s, like this form, okay? X is given equals 1, concrete number. So the left side, f prime x become f prime 1. If f is some concrete function, we can write it this and get the limit. Of course, we can write it f1 plus p minus f1 over p. P tends to 0. Why? P tends to 0. They are the same variables. If you like, you can write it in this form, 1 plus h, 1 plus s, minus f1 over s. S tends to 0. Anyway, pay attention to. They are the same variables. P, they are the same variables. They are the same variables. Try to understand the full summaries. Now look at how to get the derivative. Do you remember case 2? Yes, the limit delta y over delta x. How to remember? Step 1. Try to find the increment of the function means delta y. Delta y equals f bracket x plus delta x minus fx. Delta x means increment of the variable. Delta y means the increment of the function y. How to do? Step 2. Yes. Step 2 means do the ratio. Means find the ratio. What ratio? Delta y over delta x. Copy delta y. This expression write it in this form. Try to find the ratio. How about step 3? Yes, try to get the limit. Find the corresponding limit. If the limit exists, what is our limit? Limit is some real number. If the limit exists, so y prime equals the limit of delta y over delta x under the condition delta x tends to 0. Try to understand the 3 steps. Do the increment. Find the ratio. Try to get the limit. So now look at the question. Look at question 1. if y equals log ax, a less than 0 and doesn't equal 1, try to find y prime. How to find it? Yes, according to our definition. We write it. The first step, y prime equals f bracket x plus h minus fx over h. What is our f in this question? Our function in this question is log ax. If x equals 2 means f2, log a2. X equals 3 means log a3 equals x means log ax. How about fx plus h? Log ax plus h over h. So now we need to get the limit. How to compute? Write it. Log ax plus h over x. So we can write it in this form. X plus h over x equals 1 plus h over x. Write it in this form. We try to get the same expression. So we write it h over x times x. H is our changeable variable. X can be looked at fixed some number. So write it. Oh, we can write it in this form. 1 over x is some fixed number. So taking out before the limit signs. 1 over x. Limit h tends to 0. Let's become the power. Write it in this form. Go on, write it. 1 over x. Do you remember one important limit? 1 plus alpha. 1 over alpha. If alpha tends to 0, at this time, this expression is a constant e. So we can write it. 1 over x log ae. So we can get this result. Log ax prime equals 1 over x times log ae. We can give another special case. If a equals e. A equals e. At this time, this term rated log x bracket prime equals a equals e. Log e equals number 1. So this means 1 over x. Remember and understand. Log x bracket prime equals 1 over x. We always use this formula in the future study. So now look at this question. If f equals 13x minus 6, find f prime 4. How to write f prime 4? The first, according to the definition. So now look at this. F prime 4. F prime, any given point, f the point plus h minus f the point over h. It's the same variable. Condition, h tends to 0. So it's our definition. Try to write it, okay? The same expression. Limit, h tends to 0 over h. The value minus another value means the difference of the two values equals 13h. H is delete over. So limit 13 equals 13. It's our final result. F prime 4 equals 13. Of course, we can check the answer. How to check? F is giving f prime derivative function equals 13 for any real number. Why? Because f is a straight line, means linear line. So f prime means corresponding to the slope, so equals 13. So f prime 4 equals 13. Showing the checking work, we know the answer is correct. Now look at this question. If f equals square root x, x of course is a positive number, try to find f prime x. According to the definition, yes, always remember the definition. It's useful in this class, okay? Of course, it's useful for the future study. Now look at this. Fx. Yes, here. F equals square root x. How about this term? Who can tell me? What is our f4? Yes, f4 means square root 4. So fx plus h means square root x plus h. So we can write it in this form, okay? Square root x plus h minus square root x over h. How to do this? Time something over something. So now look at, we can write it. Limit h tend to 0. X plus h square root bracket square minus x together equals x, okay? And this term, x plus h plus square root x equals this term. H deleted together, only left this term, so equals this expression. Now look at the limit. We have learned the limit. Pay attention to the condition means variable h tends to 0. H tends to 0, this means how about x? X doesn't change, So the final result equals 1 over 2 square root x. So we can get this result. Square root x prime equals 1 over 2 square root x. Try to remember this result. So now class is over. See you next time.